All right, so now we're going to look at 2-3 and continue on for today. So everything we just did in 2-2 sets us up for 2-3. So 2-3 is all about our constant of proportionality. So that's our topic here. So when we look at a proportional relationship, there's always a constant of proportionality. So the first thing I want you guys to put on your notes, nobody gave me a copy of the notes, right off to the side of where it says constant of proportionality, I'm going to pull up a set of my own to show you where I want that written. I want you to write, yes, I want you to write y equals mx. That m is your constant of proportionality. So when we set up an equation where y equals some kind of multiple times x, that m will be a number. That m is your constant of proportionality. Oh. So those equations that we just did in 2-2, those numbers that we were finding, that number was our constant of proportionality. Because it is constant, it stays the same, and it is how the y and the x are proportional to each other. Does that kind of make sense? Mm-hmm. Because every year people look at constant of proportionality. It's a big, it's a name, but it's kind of a big name, and proportionality is a big word. People kind of get scared of it. It's just a fancy way of saying, what do we multiply x by to find y? Oh, they get scared of it because they don't really know what it means. And it's just kind of big. People get afraid of big words. So here we have the manager pay graph. So the money earned, when you have a job where you get paid hourly, your pay is proportional to your time spent working. So if he works 1 hour, he makes how much money? $10. If he works 5 hours, point B, he makes $50. If he works 8 hours for point C, he makes $80. So if we want to talk about the y value, or actually I'll use some better variables. I'll say his pay is what times the hours. His pay is what times the hours. Franny, what do you think? His pay is what times the hours? Yeah, it's just 10 times the hours. He's making $10 an hour. So now, which of those points do you think was most useful? A, B, or C? Well, A. Why? Because it gives us like a unit rate, so it tells us how much he's getting paid per hour. To find the constant of proportionality, look at what your x value of 1 is, and the y value is the constant of proportionality. So when x is 1, your y value tells you that constant of proportionality. Does that make sense? Mm-hmm. So really, what's another way we could talk about constant of proportionality? Bella just talked about this in the last lesson. The unit rate. The constant of proportionality is the same thing as the unit rate. So what I found out is this, if I let it play, still has all the sound. So I'm going to probably just normally like scooch through it. So we're looking at bricks. Back when I used to landscape, we would have to measure distances that we would build a wall on and calculate how many bricks we would need based on the length of the wall and the length of each brick. So we buy some bricks that are 20 centimeters long. So we know that as we fill in this table, one brick will be 20 centimeters. And that then gives me the ratio of 20 compared to 1. I am actually going to just pull up your notes for this. That will be easier than fighting with that. So then we see that 2 bricks are 40 centimeters. Because if each one's 20, we'd have 20 plus 20. So I want you to finish filling out this table for what would be the length of 3 bricks, 4 bricks, and 5 bricks. And then do all of your ratios down here and see what is your constant of proportionality. How do we find it? I'll give you like a minute or so. Check what people have done. Make sure you show the work in this bottom table here. This part, because this is really important. This is the big part of how do we find the constant of proportionality. Brennan, we haven't talked yet today.
Yay.
Brennan, as I have 3 bricks, what will be the length?
3 bricks would be 60.
4 bricks?
80.
5 bricks?
100.
And all of those are centimeters, remember?
Yep.
So then, Isaiah, what'd you do in this table? Like for your 3 bricks, what was the ratio that you set up initially? 60 over 3, the length of the bricks combined divided by how many bricks there are. When you do that division, how many times does 3 fit into 60? You get 20. My ratio for 4 bricks, there was your card, Brendan, funny enough. Layla, what's the ratio for 4 bricks? 80 over 40? 4. And then that ends up reducing to 20. And then, how many people I talked to? Abby? Funny enough.
Oh, I did 100 over 5.
100 over 5, what's that reduced to?
20.
So, the constant of proportionality for this situation is
20.
what? Is 20. You can always find the constant of proportionality by doing your y value divided by your x value, whatever that answer is. That is your constant of proportionality. That is also what we call m in that equation, y equals mx.
So whatever comes up the most?
It's the answer to all of those ratios. So we could say the total length of bricks is 20 times the number of bricks. Guys. So here's our equation. You might want to write this on your paper because this is going to be very useful. The length of the bricks is 20 times the number of bricks. So B would be the number of bricks. L would be our length.
I have a question.
Yeah.
Are you gonna put the assessment on digits, 2, 3, or not now?
Oh, the homework?
Yeah.
Yeah. I'll post it.
Okay.
Yeah.
Okay, how come we always put like a brick on it instead of like a circle? 'Cause that's what.
Just because it is easier to draw the rectangles.
So it pops out. My hair.
All right, so let's look at these books. So we've got a stack of books, and I will let the video for this play because it is useful to see. So we start weighing our books. Check this out.
Serious man.
We throw 3 books on
Where's his other hand?
in his pocket. Throw 3 books on the scale. We get the weight 5.25.
Why does he have a huge magnifying glass?
We throw 6 books on the scale. We get 10.5. We throw 9 books on the scale. We get 15.75. So we want to calculate what is the constant of proportionality here. And then we can use that to determine the weight of 11 books. Now, something that we have to assume here, every book in this situation weighs the same amount. So say we're using all your language arts vocab books, or all the history books, or so all identical books. So can anyone figure out how we can find the constant of proportionality here? New people.
Did you skip my
Layla?
name?
Do you have an idea? Crystal? I'll give you guys a hint. The constant of proportionality here is going to be the weight
Divided by the number.
per book.
Exactly.
I got
Franny?
15.75 divided by 9.
Yeah, per tells me to divide, so I can just take my 15.75 and divide it by 9.
Oh.
You got that for us, Karina?
I just divided it by 3.
1.75.
So that tells me that each book is 1.75, and if you want to be good, you should label it pounds. LBS from, I want to say Latin, libras. So then the equation that we could write, hopefully you have a little bit more space than I have left, we could say the weight is equal to 1.75 times the books You know what the weight of 11 books is? What do you get? 19.25. Can anyone verify that for us?
Yeah, I did.
Yeah?
I did.
Isaiah?
Wasn't the 6 books like 10.5?
So, if we took 10.5 and divided it by 6, we would get 1.75.
What about 5.25 divided by 3?
If we took the 5.25, the first weight that we had for 3 books, we'll get 1.75. It will always give you the same value because it's constant. It's the constant of proportionality. So any y divided by the corresponding x, here my y value is the weight, my x value is the number of books. So yeah, great question.
I really love where the detective didn't stack the books. You should just stack the books.
So we've got these boxes. Each shoebox is the same height. The height of the display depends on the number of shoeboxes. Well, duh. The more shoeboxes we stack, the taller it's going to get. So what is the constant of proportionality in this situation? To know that, we'd have to see that 45 inches out here. So I'm going to move my label to over here.
I got it.
So how are we going to determine the constant of proportionality? We're kind of getting through. Weird talk. Divine, do you have an idea of how we determine the constant? Pass? All right, we'll just do hands. Bella?
45 divided by 5.
Yeah, we want 45 divided by 5. Since the height is determined by the boxes, the height is your y, the boxes are your x. So when we do that, we get 9, and that'd be inches. So that's 9 inches per box. So the equation that we could use is the height will be 9 times the number of boxes. So to find the height of 12 boxes, it would be 9 times 12, which will be 108 inches. Eli.
So, to find the number of boxes, would you just have to multiply that by...
If you knew the height, then you could find the number. So let's say we're given the height to be 90 inches. So then I could set up my equation 90 inches is equal to, well, my constant of proportionality is still 9, but now what I don't know is the number of boxes. This gets a little further than we are right now, but in our equation solving, we look at the fact that this is held together by multiplication. So we would just divide by 9 on both sides, and you get that the number of boxes here would have to be 10. Because 90 divided by 9 gives you 10. Exactly. Inverse operations to solve our equations.
The first red box reminds me of the Puma box.
You know that Puma and Adidas were originally owned by brothers?
Exactly.
Did you know in England,
It's Adidas.
Adidas and Puma's Puma.
All right, so let's try this. We got like 5 minutes left. Let's try this. We have a recipe that calls, guys, order gets really important here, so I need you paying attention. I know it's a little hard with the other class being loud. 2 cups flour, 3 dozen cookies. So this is, sometimes my wife will send me to the store like, I need more flour. She looks at a recipe and immediately knows she needs more flour, because if you know you're making more than 3 dozen cookies, are you going to need more or less than 2 cups? More. As you want more cookies, you want more, or you're going to make more, you're going to need more flour. Sorry. So if we want to use 3 cups of flours to make 60 cookies, that's a different recipe. So we've got 2 different recipes here. Actually, I may, so that you don't get confused with them being 2 separate recipes, I'm going to underline these. The green highlighter looks really bad in the video. I don't know why, but so I may use the green highlighter less now. So are the constant of proportionality the same for the 2 recipes? Are the recipes the same, or for the same cookie? So, I mean, if they're the same, if they have the same constant of proportionality, we could assume it's the same recipe. Now, before we can really jump into this, We have 3 dozen compared to 60. Well, 3 dozen, can't we kind of simplify that?
36.
It's 36 because each dozen is 12.
5 dozen cookies is 5 dozen. Or,
So,
60 cookies.
back up. Let's take your recipe. Your recipe made 36 cookies with 2 cups of flour. I always think it's easiest if we've not really been told what we have to do, put your bigger number on top. So let's make our constant of proportionality here our 36 divided by, well, if that's number of cookies, then that would have to be compared with the amount of flour. So how much flour did we use? 2 cups. So the cookies per cup of flour, what's 36 divided by 2? 18. So that tells me that I can make 18 cookies for every cup of flour.
That's not funny, dude.
Your friend's recipe, how many cookies?
60.
Yeah, try to use hands, guys, so we're not all talking over each other. Then that would be divided by,
3 cups.
3 cups.
Of flour, to be specific.
Yeah, so still again, it's cookies over flour.
And which equals 20.
So that's going to be 20 cookies per cup of flour. Are the recipes the same?
No.
No.
They're close.
So your friend's recipe makes more cookies per cup of flour. She gets 2 extra cookies per cup of flour. So would those be the same cookies?
No.
No. If it uses a different recipe, if it uses a different ratio, got to be different cookies.
They're almost by 2.
Okay, so we're assuming same size. Like cookies is like a standard size here.
Cookies is around, like a perfect circle.
Now, things I really don't like doing, running on a treadmill.
I love doing that.
So on Monday, you ran 2.25 miles in 22.5 minutes. On Tuesday, you ran 2.35 miles in 25 minutes. Are your constants of proportionality the same? So let's set up Monday first. Do we want to do distance divided by time or time divided by distance?
Time divided by distance. I mean, distance divided by time.
Distance divided by time.
It really is your choice. Now, when we talk about speed, how do we talk about speed? Like when you're driving in the car with your parents?
Miles per hour.
Miles per hour. That's distance divided by time. So that's how we normally do it. But here, because my minutes are more than my miles, we could take time and divide it by distance if you want to. But that just means that for Tuesday, we'll also have to do time divided by distance. So we have the same comparison happening. So if we do time over distance, that's 22.5 minutes over the distance of 2.25. That's how we find that rate. Finish out by solving Tuesday's rate and determine, did you run at the same speed? If not, which day did you run faster? So I'll give you like a minute or two to figure this out.
Cheating. Wait, can you use a calculator?
Yes, you may use a calculator.
Bible saying that I can do it.
Guys, we're getting into the work that kind of uses lots of like harder, more specific values, decimal values and things like that. So use a calculator if you need.
I don't like using the finger on my phone, but I am.
Calculators aren't good.
I really don't like the iPhone calculator.
Exactly.
The TI-30 shows you everything that you have typed and it just keeps it there while you look at your answers. So it's just much nicer for your brain.
I agree that to the office, please.
Are you paging just my room?
Yes.
She's in Hemmer's room.
Thank you.
Yep. So, who's got my time per mile for Monday?
10.
22.5 compared to 2.25. This is just 10 times. So now I'm on so hold on, let's label that then. That is,
10 miles per hour.
it's not miles per hour.
Miles per minute.
It's minutes per mile.
Oh.
Because you did time divided by distance. Your time was in minutes, Your distance was in miles, so it's minutes per mile. So they are running a 10-minute mile. Who's my runners in here? Is a 10-minute mile good or kind of slow?
Yeah, that's okay.
It's like, so for middle school, that'd be a decent time. Once you get like up into high school and stuff, you want to have more like an 8-minute mile, a 7-minute mile. Like if you're running competitively. Now it depends whether you're sprinting or whether you're running distance. Brendan, do you know my Tuesday?
Yeah, so you're gonna do 25 times 1.3.
Yeah, what do you get?
And then I got 10.638.
10.638. I know, it's time. So are they the same?
No.
No, and since this is minutes per mile, which day was faster?
Tuesday.
Monday.
I mean Monday.
Tuesday took you longer to run the same distance. All right, go ahead and try the homework. I'll get it posted by AO, guys.